the most complicated of all probably. Please pause the video and try doing it yourself. 6 chocolates different and 4 children. Everybody has to get at least one. So this can be done in how many ways? One way is 1, 1, 1, 3 and 1, 1, 2, 2. Imagine there cannot be a third way. Now think how many ways are possible. Of course, these are 2 different ways. So whatever the number of cases you have to find and then add the number of cases. In this case, first of all, let's figure out in how many ways can children be selected in such a way that 3 children get 1 chocolate each and 1 child gets 3. So imagine you can intuitively think that you have to just select this 1 child who gets 3 chocolates. In all, there are 4 children, so this can be done in 4 ways. Or if you want to do it mathematically, then 4 factorial upon 3 similar numbers, 3 children who get equal number of chocolates. So upon 3 factorial, children can be selected in 4 ways. I would say intuitively, you have to just select which 1 child will get 3 chocolates. In this case, now mathematically again, there are 4 children, out of which now 2 are similar here with 1 chocolate each and 2 with 2 chocolates each. So this is 24 upon 4. This can be done in 6 ways. So children can be selected in 4 ways and 6 ways respectively for the 2 cases. Now come to chocolates. We have 1, 1, 1, 3. So 6C1, 5 remain. For next one, 5C1, 4 remain, 4C1, 3 remain, which is always 1. In this case again, 6C1, 5 remain, 5C1, 4 remain, so 4C2, 2 remain. The last part is always 1. So this is 6 into 5 into 4 into 1, which is 120. And this part is 6 into 5 into 6, which is 180. Total number of cases 4 times 120, which is 480, plus 6 times 180, which is 1080. Total is 1560. That's the answer. There are 3 ways of doing it. 2, 2 and 2. That means each child gets 2 chocolates. Then 4, 1, 1 and 3, 2, 1. So first, let's consider the cases for children. This can be done in only one way because each child is getting same number of chocolates. In this case, it is 3 factorial, but then 2 children are getting similar number of chocolates. So upon 2 factorial, this is 3 and 3 to 1, all 3 children are getting different number of chocolates. So all 3 factorial, this is 6. Now let's consider the cases for distribution of chocolates. 6 chocolates, the first child gets 2. So 6C2, 4 remain into 4C2, 2 remain. The last part is always 1, 2C2, 1. In this case, 6C4, 2 remain, 2C1, and the last part is again 1, 1C1. And in this case, 6C3, first child is getting 3. Now 3 chocolates remain. Next child gets 2. So 3C2, last part is always 1. This 6C2 is 15, 4C2 is 6, and 2C2 is 1. 6C4 is same 15 into 2 into 1. 6C3 is 6 into 5 into 4 upon 6. That's 20 into 3 into 1. So this is 90, this is 30, and this is 60. Now total number of cases 1 into 90, 90, plus 3 into 30, 90, plus 6 into 60, 360. Add it up. It's 90, 180, 360. Total is 540. That's the answer. This was the concept, guys. GMAT shorts are deliberately kept brief. For an elaborate explanation, please refer the stage 1 videos. Thanks for watching.